All right, gentle people, today the plan is to look at what does the quadratic form tell you? What information can you get when you're just looking at the equation itself without having to do a calculation? And we'll be looking at not only the quadratic form, ax squared plus bx plus c, we'll be looking at the factored form, and we'll also be looking at the completed square form, or the a open bracket x plus h close bracket squared plus k. We'll talk about that. But in order to do that, we need to be able to visually represent what we're looking at. And so we're on the geogebra.org website. I'll link that in the description. And I'm not signed in, which is good. And that means that you can also use this for free. And it will allow us to see what we're doing. So without us having to plot points and draw tables and find x and y values, we can just put in our equations, right? So I'm going to type here. Let's start with y is equal to x squared here, and I was able to type that in just using the keyboard, or alternately you could have clicked here to enter or input your formula or equation. Right now, GeoGebra is a website that's been around for a while. You can go to YouTube, you can see some videos on how to use it. I've been teaching a very long time. I've meant to visit this app, so this is going to be a learning experience, not just for you, but for me as well. But as I said, we're starting with y is equal to x squared, and the very first thing that you need to know, any polynomial actually tells you its shape by virtue of the highest power that you have, right? So in a quadratic, our highest power is going to be x squared because the form is ax squared plus bx plus c. So the highest power of x is 2, and once you know the highest power, the number of turns that you want to get is 1 less. So if I have x squared here, then I expect that since the power is 2, the number of turns is 1, and I get this shape, which is called a parabola, right? This is a parabolic shape. Now, the direction that it opens up to, whether it opens up or it opens down, whether you have what we call a minimum curve or a maximum curve, depends on the number that multiplies x squared. So if the number that multiplies x squared, as we're seeing here, is positive in 1 or 6, what we end up with is a minimum curve, one that opens up, right? Now let me change this to something smaller, like a half. Now, the smaller the term, and when we get to transformations, we'll talk about why this is, but just I want you to notice these changes now. The smaller I make the coefficient, the wider this graph is going to be. So if I have a half there and I change this to a sixth, it's going to get wider. I could go to 1/9, it gets wider. But if I make it larger, maybe in the order of 4, it gets narrower, right? Let's keep it at 1 for now. Or let's try 2, right? Now, if I were to make this a negative 2, it now becomes a maximal curve, right? Where we have a maximum point here. And this makes sense, right? Because again, no matter what you do to x squared, the values are always going to be positive, right? And the larger you get, you're going to get large positive values with if you're inputting values of x, they're going to be squared and you're going to get big values. But if when you finish squaring, you then multiply by a negative, then all of those values become negative. So the majority of the values that you're going to get out of y is equal to negative 2x squared are going to be negative, with the exception of the situation where x is 0. Once x is 0, then this whole thing becomes 0, because 0 times anything is 0. And so you have that the highest point being 0, 0. And that would make it, of course, a maximal curve, because if one point is 0 and everything else is negative to the left or right of it, then you get this thing opening downward. Conversely, if this is positive, then everything that you put into every x term that you put in here is going to end up giving you a very large positive number, or relatively large positive number, with the exception of 0, which would be the smallest value, and that would be a turning point as well. So 0, 0 is our turning point here, right? If I made that x squared, doesn't really change much. Again, the number that you multiply, that a value that you're multiplying x squared by, is just going to tell you whether you're curving up or down. Is it a maxima curve or a minima curve? If it's positive, minima curve. If it's negative, it's a maxima curve, right? Cool. First thing to note. Next, what happens? Oh, let's zoom out a bit, right? What happens if we add to this a 7x? Let's do that. Let's try this in another line, all right? Let me go call this function g, and we're going to go such that y is equal to, let's go x squared, but I'm going to add 7x. Oh, all right. So that is added as a power. I don't want that. I needed to have pressed something. Let me get that right. All right, we're good now. Plus 7x. All right, let us see what happens. Now, with this, all you have done effectively is kind of shifted your turning point. And in shifting your turning point, you're essentially shifting the graph itself, right? And that will happen if you add a 7x or you subtract a 7x, you're shifting this thing. It's basically to the left or right and down. And we'll talk about why that is a little bit later, because again, all we're looking at is, just basic ideas of what is transforming or what do we have with these graphs, right? Let me revert this to positive. And again, x squared tells us you have a single term with a maxima or minima that will be determined by the number that multiplies the number that multiplies x squared. And if I add to that x squared 7x or a bx, all that does is to kind of shift our our graph, whether left or right, and a little bit down, right? So you're comfortable there, right? Now, what happens if I then add a 10 to this? Well, it's almost the same graph that we had, but instead of being shifted, and let's look at what that looks like as a matter of fact. Let me kind of duplicate what we have here so you can compare all three graphs. Let's call this H. All right, and I'm going to hide the original graph a little bit, and we'll look at these two graphs, right? Now with G, we already know that if we looked at F originally, and let's look at F and G, that we shifted our turning point to the left and down when we added 7x, right? Now, in adding 10, we're actually just going to elevate this graph. And that's because what we're actually doing is we're changing what we call the y-intercept. Now, what is the y-intercept? Well, it's that point where your graph is going to cut the y-axis, and it happens where x is 0, right? So for our g, let me hide everything else. For g of x, we could have said that y is equal to x squared plus 7x plus 0. So this graph, its y-intercept is 0. Our initial graph here also had a y-intercept of 0. But the only difference is that here, our minimum point was also 0. The second that we shifted this minimum point, we still retained a y-intercept of 0, because there's a constant that's we don't have to write because it's 0 here. And so it ends up cutting right here. Now, in adding 10, what are we doing? We're adding 10 here, and that means that when x is 0, that y must be 10. So we'd expect that this is our current, for G, this is our current y-intercept. All that's going to happen is that the graph is going to shift up here. It's going to shift upward by what looks like 10 units. So whatever value this is, what is the value of G? Negative 12.25. If it shifts up 10 units, we should expect that our turning point is going to be negative 3.5 minus 2.25. So let's check. Let's click here for the extremum. There you go. All right, so those are the three things that you get from the quadratic form ax squared plus bx plus c. You get the number of turns, you get the directionality of your curve, whether it's a maximum or minimum curve. You get whether or not you're shifting your turning point a bit, your maximum or your minimum point, and you get a y-intercept value. All right, let's look at the same graph. And I'm going to look at this graph specifically, but I'm going to look at it in a different form. Let's see if we can get H. Let's call this, I'm going to call this I because we know our alphabet, right? But instead of the format that we're used to, that we just wrote a while ago, let us go with the factored form, which should be x plus 5, and you guys can factorize x plus 2. Now you notice that for both of these, and this, I need to change the color on this. Let me see if we can change the color. Settings, we want a color that stands out a bit more. We don't have we don't have a yellow, right? Cool. All right, so having done that, right, I can hide this and I can show it. And you realize that there's overlap, and that makes sense because guess what? This is a factored form, I is a factored form of H. So that makes sense that they both overlap. But what do you notice? Let me zoom in a bit if I can. Let us zoom in. What does this form tell us? Well, this form tells us the solutions of the graph. Now, when I say solutions, you might say, what? How are you solving anything here? Well, the idea is this. It's pretty straightforward. When you actually look at x plus 5 times x plus 2 and you equate it to 0, you're looking at two graphs. You're looking not only at x plus 5 plus x plus 2, but you're also looking at y is equal to 0. And I need to give this a separate color. I don't like this color for this one. Let us go settings. I want something that stands out a bit more. Did we have green before? I don't even know if I had green, but let's go purple. All right, cool. Now, when you say x plus 5 times x plus 2 is equal to 0, you're really saying graphically, where does the graph of x plus 5 times x plus 2 intersect the graph of y is equal to 0? And when you solve this, you would say, well, it happens, if this times this gives me 0, it happens when either this is 0 or this is 0 or both are 0. So if this is 0, x plus 5 is 0, that means that x is equal to negative 5. If this part of the bracket is 0, then that means that x plus 2 is equal to 0, which means x is equal to negative 2. So when you factor and you write an equation in the factored form, what you are giving is what we call the solutions, the roots, the points that when substituted into your function give y is equal to 0. So when you have factorized, your next step normally is to solve, and the solutions that you're getting are what we call our roots. In this case, negative 5 and negative 2, because those values when substituted in either of these brackets is going to end up giving you 0 as a result. So our ax squared plus bx plus c form gives us, again, let's go over it. It gives us the number of turns, which you know to be 1, and we get the parabolic shape. The coefficient a, if it's positive, gives us a minima curve. If it's negative, gives us a maxima curve. If you add a bx to it, you're shifting your turning point, left or right and a little bit down, right? And if you have a constant at that end, the constant at the end is your y-intercept. Now your x plus 5 times x plus 2 factored form is going to give you your solutions or your roots. We have one more form. And I'm going to tell you what I'm doing. And I'm going to ask that you try this on your own ahead of me. Complete the square for this equation here. And let me just remove these two so we have a clean slate, so to speak. This function is equal to that function, right? if you complete the square for this, what do you get? So pause the video here, work ahead of me before I put this on the board, right? So I'm going to give it this function if I can. Give me 1 second. I should have it right here because I'm not working this out right now. So I'll just enter it for you. So if I were, and if this is the same thing, when I rewrite it in the completed square format, then guess what? It should overlap with what we already have, right? With these two forms here. So if I have y is equal to, and let me open a bracket here. And in the bracket, I'm going to have x plus 3.5. All right, I'm going to put x, whoops, in the bracket. Let me get back in the bracket. X plus, and I said 3.5. You know what? Let's do it this way. We can complete the square, right? It should be plus 7 over 2. All right, all squared. And minus, and you know what? I shouldn't have to do that. Let me write out the whole thing because it would be plus the 10 minus 7 over 2 all squared. Let's see if I can get that 2 up there. All right. So this is a shorthand. It's really another way to write that. And let me, before I do that, let me show you that all three of these overlap. So if I hide these two and then I show this one and hide this one, same graph. Show this one and hide this one, same graph. Show this one, same graph. So all three of these are the same graph. So that proves to you that this completed square form is correct, right? But if we were to simplify this, the simplification for this is actually, and let me just simplify it, it should be minus 2.25. So let me go minus 2.25 and not squared, just minus 2.25. And you notice it hasn't changed, right? And instead of 7 over 2, we could effectively just have 3.5, right? And again, you notice it doesn't change. So all three of these are the same thing, right? But when I look at this first equation, let me hide the others. If I wanted to find out what the turning point was, I could click here, right? And the extremum is minus 3.5 minus 2.25. Okay, but then look at this equation. These values are the values that you get when you make, well, when you find the x value that makes this bracket 0 here, the term in bracket 0. You also happen to find the y value for your turning point. So what value makes x plus 3.50? Well, negative 3.5. But when this is 0, y itself is equal to negative 2.25, and that means that my turning point is negative 3.5 minus 2.25. So the completed square form gives you the turning point. So let's kind of just go back over what it is that we're seeing really quickly. What do I get from the ax squared plus bx plus c form? I get a couple of things. I get the fact that it's a parabola because the highest power is 2. So I have one turning point, whether that is a maxima or minima. In this case, it's a minimal curve because the coefficient of x squared is positive. If the coefficient of x squared was negative, it'd be a maxima curve. Cool. What else do I get? I have the 7x here. I know I'm shifting that turning point a bit, right? Whether it's to the left hand down or to the right hand down, right? What else? Well, in this case, it was to the left hand down. What else? And I don't have to know by how much because that's what the completed square format is for. What happens when I have the plus 10 at the end? The plus 10 at the end gives me the y-intercept. So what does that mean? This graph is going to cut here, the y-axis, at this point. And I should be able to click on tools, click on point, and click here. So you can see that. Let me click back on move. Now, if I click on this point here is 0, 10. That's your intercept for h and the y-axis. Cool. Let me minimize this, shift it up a little bit. Kind of like this a little bit bigger. Let me shift this up. What does the other equation give us? Well, the other equation gives us our roots, right? It's going to tell us where this graph cuts our x-axis, and your x-axis is y is equal to 0, right? and that would be at these 2 points here, at this point here and at this point here. All right, those are our two intercepts for h, right? And we call those roots or solutions. Finally, what does the completed square format tell us? Well, that tells us our turning point, our extremum, which is negative 3.5, negative 2.25. How do we get that? We need the value of x that makes the bracket 0, and that's negative 3.5. And once this is 0, the y value becomes negative 2.25. All righty. I just wanted to kind of have that discussion with you to give you an idea of the information that you get just off the bat looking at these forms of the same equation. These are areas that we're going to go into for further understanding. In the meantime, jump on geogebra.org. Again, I'll put that in the description. Start creating, start messing around, start tinkering, learning. It's a good tool to use. It's a good tool to have. I am late to the party, and there's a ton of information and tutorials on how to use this app. So I'm going to send this your way. Of course, noises in the background. Don't forget to like and subscribe.